Let's now use the map and the forEach methods to compute usernames for each account owner in our application. So we have these 4 accounts, and for each of them we want to basically compute a username. And the username is simply the initials of each of the users. Okay, so let's just start with one of them, just with one string to make it really easy, and then we will generalize that function for the entire accounts array that we have down here, so which contains all of the accounts. But for now, I will just grab this string here and create a username for this one. So let's do that down here after this first function that we created. And for now, we will do this outside of a function just to see how it works. And then afterwards, we will create a new function. So let's say the user is this one here, and we want to compute the username. So for this one here, the username should be STW. So that's just the initials in lowercase. And so let's do that. So we start by transforming this string to a lowercase. So we already know how to do that. And now we simply want to take the first letter of each of the words. All right. And so we need to basically split up this string into the multiple words. So this is a very common use case for the split method. So dividing by spaces, which will divide the string into words. And let's just take a look at what we have now so that we can discuss our next move here. So username, and so right now we have Stephen, Thomas, and Williams. And so how do we take each of the first letters here? Well, we could simply loop over the array and then take the first letter in each iteration and add them into a new array. And then in the end, we would join that array and we would end up with just a string of STW. Okay, so let's do what I just said. So looping over this array, taking the first letter and then putting it into a new array. And that is exactly what the map method does, right? Now we can do that directly here because this split method here returns an array. And we can then call the map method on that resulting array. So we can immediately do .map here, just like we can call the split method on the result of the toLowercase method, because this one here returns a string and split is available on all strings. Okay, so let's define our callback function here, and I will start by doing it with a regular function. And so here, let's say we get a word or a name. It doesn't really matter here. And so in each iteration, what we want to do is simply to return the first letter. So that's name at position 0, right? And so right now, this should be an array with only these 3 initials. So let's see. And yes, beautiful. That worked just fine. And so the result of this here, of this whole thing, is now an array. And on an array, we can call the join method. So, .join, and simply by an empty string, and this will give us the final result of STW. All right, great. Now let's simplify this callback function here. And again, I will start by deleting the function keyword. Then we can also delete the curly braces. And finally, also delete the return. And so see how simple this has become now. So we transform name to name at the first position. So just the first character. And one more time, don't forget that this is actively returning here. We just don't see it. Okay, but the return is happening. And this is the reason why this works. Because the callback function in the map method always needs to return the new value that should be in a new array. All right, so this works great with this username. Let's now take this actually into a function. So I'm cutting it here, and let's say create usernames, create a function, add this here, and for now, let's say we get the user in here. And so now we can call the function with this string. Oh, and here I called console.log instead of create username. Okay, and yeah, if we want to see the result, we would also have to log it to the console now. So of course, first returning the username and then log it to the console here as well. And so indeed, we now get the same initial that we had before. But now we actually want to compute one username for each of the account holders in our accounts array. All right. So to do that, should we use the map or the forEach method? Well, we do not want to create a new array in this situation. All we want to do is to modify the objects, so the elements that already exist in the accounts array. So in this array here, right? And so what we want is to simply loop over this array here and then do something. And so for that, we use forEach. All right. So let's modify this function here some more. And instead of simply receiving one user, what we want to do is to receive all the accounts. So basically an array of accounts. And this goes back to the philosophy I explained to you in the last lecture, which is that each function should actually receive the data that it should work with instead of using a global variable. So that's exactly what we did here with the movements, which we could have read directly from the global variable of account1.movements, for example. But instead, we created a function that receives that data and can then work with that data or with any other data that we choose to pass into it. And so here we are doing the same. We do not want to rely on the accounts array that we already have, but instead we want to pass it into the function. Let's get rid of all of this. And so what I mean is to actually pass the accounts array in here. And here it doesn't have to be called accounts. Let's just call it like this as an abbreviation. Okay, just to remove a little bit the confusion that you might have. Okay, and now as we were saying, we need to use the forEach method here because, again, we do not want to create a new array. We simply want to modify basically the array that we get as an input. And this is a really important distinction to keep in mind. So here we are again talking about the side effects that I mentioned in the last video. And in this case, the side effects are going to be to change, so to mutate the original accounts array. And so that's what we want to do here. And so forEach is the way to go. So for each account in the accounts array, so I'm just calling this ACC, which is again an abbreviation for one single account. So for each account, we now want to do this here, basically. So let's grab all this. We can remove this. And so let's create a new property on each of the account objects. So account.username, and that will be equal to user.owner, owner. And so let's check out why that is. So each of these accounts has the owner property. And so that's where the name of the owner, so of the user, comes from. So we take that, so account.owner, and create our username from that. Okay, so that's what we do here. And then we create a new property on that account element. And yeah, and that will then contain the username that we create here. Okay, here we have some kind of error, and of course it's not user, it is account.owner. And now that's it, right? And in this function we do not return anything because, again, what we're doing here is to produce a side effect. So we are doing something to this account object here, and so there's no need to return anything. We are just doing some work here, basically. We are not creating a new value to return. Okay? Now, if we want to see if this actually worked, we can log this accounts object or this accounts array to the console. And so in there, we should now see our objects with a new property. And indeed, we get the username of JS, and this one should be JD. And here are Stephen Thomas Williams, and indeed, it is the STW that we had previously worked with. Okay? So, in this lecture, it was very important to understand the use case for the map method here, which was perfect because it allowed us to create a new simple array which only contains the initials of whatever name it is used on. And then, on the other hand, the forEach method was a great use case to produce some so-called side effects. So, in other words, to simply do some work without returning anything. And so that's what we did here. We simply looped over the accounts array, and in each iteration, we manipulated the current account object and added a username to it based on the account owner, plus all of these transformations that we had already done before. So a couple of interesting and important takeaways from this video. So make sure to review it properly, and then let's move on to our next transforming method, which is the filter method. Now let's learn about the filter method, which, as we learned before, is used to filter for elements that satisfy a certain condition. And how do we specify such a condition? Well, you guessed it, we use a callback function again. So let's again work with our movements. And so now the filter array. And once again, I will start with a regular function. And just like the other callback functions, like in map and forEach, this one also gets access to the current array element as well as the index and the entire array. But let's only work with the current element here, which in filter is usually all that we need. Okay, now what we want to do here is to create an array of the deposits. So let's actually write that. So deposits, and deposits are only the movements that are above 0. So we already know that, right? Let's indeed take a look at the movements here. So here there are, and so we want to filter out these negative values. And so that condition is so that only the values that pass the condition will then make it into the new array. And passing that condition means that it's true. So we will again return something here. And here the trick is that we return a Boolean value. And so in this case, all we need to do is to say the current movement greater than 0. And that's it. And so now only the array elements for which this condition is true will make it into the deposits array. All the other ones will simply get filtered out. So they will not be included in this deposits array. Okay, and in fact, we only get the positive values now. Beautiful. And that's actually it. That's really simple, right? So just as I told you, if you know how to use the callback function correctly, and if you know how and why it works, then all of these methods become really, really simple. And once more, I also want to use the forOff loop here again, so that you can appreciate the difference. And that's very simple. So we need, of course, the same condition. So if the current movement is greater than 0, then we want to push the current element into a new array. So we need to create that here, deposits for, and start again with an empty array. And so in this case, we simply push it there. So we push the current movement. And so let's take a look now. And as expected, we get the same result. And so you could again ask, what is the big difference here? Like, what's the big deal? And why not just use the for loop for everything? And the reason for that is, again, the push that exists in JavaScript for using more functional code like this. But there's also a more practical implication here. And that's because we can actually chain all of these methods together. So basically use them all one after another to build a big final result. So a bit similar, in fact, to what we did here in our application right here. But here we mixed string methods with array methods. But later on, we will do like big chains only with array methods. And that would be completely impossible using the for loop. So that's another big advantage of using the methods instead of the regular for loop. Now, anyway, I have just another small challenge for you here, which is to create an array of the withdrawals. So withdrawals like this. So I want you to create this array without looking at the code we already wrote. And so the withdrawals should only include the negative numbers here. So pause the video now for a minute and please try to write this code on your own. Okay, so hopefully you did that. And so it is movement and again dot filter. And now I will use an arrow function here. So I will leave this one with the regular one and now an arrow function. Okay, and now mov less than 0, and that's it. This is our condition, and never forget that this one is actually returned here. So again, it is like having return written here. And so this is why this works. Let's log it to the console. And yeah, only the negative numbers remain now. All the positive ones got the result of false here in this condition, and so therefore they were not included in the withdrawals array. And again, these callback function here also get access to the current index and the whole array. And I will just leave it here, but I never used these in my life ever in the filter method. Okay, so this was the second of the data transformation methods. So that's map, filter, and reduce. And so in the next video, we will then talk about reduce. In this video, we're going to talk about the third data transformations method, which is the reduce method. And as you remember, we used the reduce method to essentially boil down all the elements in an array to one single value. And we talked about the example of adding up all the numbers in one array, right? And so let's try that now with our movements array. And remember that array looks like this, okay? And then by adding up all these numbers, so both the deposits and the withdrawals, we end up with the global balance of the account, basically. So let's start using the reduce method here. And so as I just said, we're going to call it on the movements array. And the result of the reduce method will be, as I just said, the global balance of the account. So let's call the result balance. And remember that in this case, this balance will be simply one value and not an entire array. Okay, so the reduce function also gets a callback function, but this one is a little bit different from the other ones, like the one in map or forEach. So in these other callbacks, the first parameter is always the current element of the array. Let's call it current. The second one is the current index, and the third one is the entire array. But here in the callback function of the reduce method, the first parameter is actually something called the accumulator. So let's call it ACC like this as an abbreviation of accumulator. And this accumulator is essentially like a snowball that keeps accumulating the value that we ultimately want to return. So in the case of adding all the elements or all the numbers of an array together, that will be the sum. So let me write that here. Oops. So let me write accumulator is like a snowball. All right. But anyway, let's now write the actual function block here. So as always, this callback function here will be called in each iteration of looping over the array. So reduce also loops over the array and calls this callback in each iteration. But now, what will we actually do in each of these iterations? Well, since the accumulator is the value that we will keep adding to, what we're going to do here is to add the current value to the accumulator. So, the accumulator plus the current value. Okay? And this works because in each call of the callback function, the accumulator will be the current sum of all the previous values. And so we will really keep adding to this accumulator in each iteration of the loop. Finally, we also need to return this value here from the callback. And so this is how the new accumulator can then be used in the next iteration of the loop. So basically, in each loop iteration, we return the updated accumulator, so the current one, plus the new current value. And so like this, we can then keep adding to it in the next iteration. Okay? So this callback function is the first argument of the reduce method, but the reduce method actually has another, so a second parameter. And that is the initial value of the accumulator. So the value that we specify here, which in this case is going to be 0, is the initial value of the accumulator in the first loop iteration. And so in this example, we want to start counting, or we want to start adding at 0. And so therefore, we simply specify 0 here. Okay, and with this, we should be able to already take a look at our balance. And yeah, so we have one single number. So indeed, everything was reduced, was boiled down to this one number, which we can suppose is all of these values here added together. All right. And to make this even more clear to see, let's actually always log the accumulator to the console. So let's say iteration number I, and then the accumulator in there. Okay, so we see that in iteration 0, the accumulator is 0. And so this is the value that we specified here as the starter, so as the initial value. Then in the second iteration, the accumulator is already at 200. And that's because that is the initial value plus the current value in the previous iteration. So that was 200 there, right? And so this 0 plus the 200 creates the new accumulator, which is then in the next iteration 200. Then in this iteration, we add the current value again, which is 450. So that result is 650. And therefore, in the next iteration, that's the value of the accumulator. Okay? And so here you can really see like the snowball effect of all of these values adding up to one final value. And in the end, that value is essentially the accumulator. Now here we see the value going down because in this iteration we are adding minus 400. And so 250 is 650 minus 400. Okay, so in the last iteration, the value is 2540, and then adding 1300 will eventually result in this value here. Great. So this is really how the reduce method works, and I think this log here is a great visualization of that. Let's give it all the space we need. And let me just change this one here to 100 so that you see the effect of changing this. And so now we can expect this accumulator in the beginning being 100. And so we already start with a small snowball here, which then we keep adding to. And therefore, our final balance is now 100 euros or whatever it is, larger. Okay? And yeah, let's one more time do the same thing manually, basically with a for loop. So of movements, and so we need one more time an external variable here, which is going to be the sum. Let's call it balance 2. So balance 2 starts at 0. And so essentially this is our initial accumulator value, just like this 0. And then sum plus equal the current movement. And if we log balance 2, we will get, okay, now of course, this has to be balance 2, but now we get indeed the same result. And so here you can see this common pattern that we always need an external variable whenever we want to use a for loop. And that's fine if you only need one loop, but it starts to become really cumbersome and unpractical when we use many loops for doing many operations. So these methods that we've been studying, they completely avoid this extra variable, and they simply return the variable or the value actually right away. All right. And of course, we can write this here in an even simpler way. So using an arrow function, and I will still keep this here so that we can see the return that's happening. So first we can get rid of this, then we get rid of this. We also don't need any of these, but here we always use or need the accumulator and the current value. So here we need parentheses, then the arrow, and then, as always, we can get rid of all of this. And so now still our balance is the same. Awesome. So understanding how the reduce method works is something really important, but it's also way more confusing than the other ones. But I'm sure you're well underway of really understanding it. And now that we know how it works, we can actually now also calculate the balance of these movements here, and then print that balance right here to our application user interface. And so, let's go ahead and do that here. So finally back to our application here. And so let's do that down here. So calc and print balance. And so this function here will once again receive the movements as an input. So any array of movements will work. And so now let's calculate the balance based on this array. And essentially this is exactly what we wrote before. So that's movement dot reduce, but it doesn't hurt to write it here again. So remember, the first parameter is now the accumulator, and only the second one is the current value. So let's call it the movement now. And so here simply we return the accumulator plus the current movement, and we start at 0. Great. And now all we need to do is to display it here in this element. So let's check this out, and it is called the balance value. And just like before, I already have it selected here, and this is a label. So balance value is here, so I called it label balance. And so label is basically all the things where we simply want to put some text in. All right. So let's say label balance dot text content, and this one we already know equals the balance. And let's actually do a template string here, or a template literal, and also display the euro sign. Well, I don't know where it is, so let's just write EUR, which also means euro. And so now, let's see. Of course, we didn't call the function yet. So let's do that here as well. And actually, let's put this function here where it makes a little bit more sense, because it kind of belongs to this display movements here. Okay, so let's actually also call this one here calc and display balance. So to give it a similar name as that one. And so now I'm going to call it calc display balance. And once again, I'm calling it with account1. So account1 dot movements. And then later on, as we keep developing this application, of course, these movements here that we're going to use will be from the account that logged into the application. So if Jonas logged into the application, then Jonas's movements will be shown and Jonas's balance. But if Steven logs in, then of course Steven's movements and Steven's balance will be shown here. And right now, we already see our balance up here. And so this actually happens to be exactly the same we calculated before. So also 3,840, because the movements are indeed also exactly the same. Great. So that's beautiful. With this, we actually already completed some parts here of our flowchart. So let's also keep this one handy here so that we can keep looking at it. And so we already did calculating the balance and displaying the balance. So we did all this in just one function. And we also already have displaying the movements. So indeed, we are making some nice progress here. And the rest that you see here will be even easier as we go on. Now, just to finish this lecture here about reduce, let me show you one final example, because we can also do other stuff than just adding up values. That would become boring at some point, right? And so we can also do other stuff. So this time what I want to do is to get the maximum value of the movements array here. Okay, so in this case, the result we're looking for is this 3,000. Okay, and so for that, we can also use reduce, because remember, reduce is for boiling down the array into just one single value, but that value can be whatever we want. So it doesn't have to be a sum. It could be a multiplication or even something completely different, like a string or an object. But here we will keep working with numbers, but this time we want the maximum number. So let's kind of go manually through this array to determine what the reduce method should do. So let's start here at 200. Is this the maximum value at this point? Well, we don't know yet because we just started. So let's save 200 here mentally as our current maximum. Then we move on to the next value and we see 450. So is this greater than our current maximum, which was 200? Well, yes, it is. It is greater. And so 450 is now our current maximum. Then minus 400 is of course less than our current maximum. Then we move on even further. So 3,000, is it greater than our current maximum? Yes, it is. And so that becomes our current maximum. So we store this 3,000 and then we keep going through the array. And as you see, there's no other value greater than 3,000. And so in the end, our maximum was this one. So 3,000. Okay. And now all we need to do is to essentially translate this into code using the reduce method. So let's call it max movements.reduce. And as always, we need the accumulator and the current value. So I'm calling it movement here again. All right. And now this time, what should be the purpose of this accumulator value? So that's always the big question that we have to ask when we use reduce. So up here, when we wanted to add all the numbers together, the purpose of the accumulator was to keep track of the current sum. And so here, the accumulator will be the one that will keep track of the current maximum value. So let's just start by writing the logic here in a bigger way so we can understand what's happening. And then I will simplify it to make this a one-liner function one more time. So translating the logic that we just went over here is to say, if the accumulator is greater than the current value, which is the movement, then return the accumulator, right? Because in the reduce method, we always have to somehow return the accumulator to the next iteration. And in this case, we simply want to keep the accumulator at the value that it already is and not change it. Okay? We want to change it in the other scenario, basically. So when the current value is greater than the accumulator. So that would be this case here. So here, remember, the current value is 450, but the accumulator is 200. And so now the movement is greater than accumulator. And so what we want to return here as the accumulator in the next iteration is the current movement. And so that's it. Okay. And now we also need the initial value. And so the initial value makes sense to be this first value here of the array. Okay. And so that's movements at position 0. Now we could have used 0 here, but that would not be correct. Because imagine that the first value would be like negative. Then this might not work as expected. Maybe it might work with the maximum, but not with the minimum, for example. So don't just put 0 here when you're trying to find a maximum or a minimum value. Always just go with the first value of the array. Okay, and that's it. Let's see if it works, and then we can maybe go over this again. So, indeed, we get 3000. So, we started at 200. So, in this iteration, is the accumulator greater than the movement? Well, it is not, and so return the current movement. Okay, but the first iteration is not that important. It gets interesting here in the second one. So now our accumulator is at 200 and the current movement is at 450. So this one here is false again. And so now we return the movement as the new accumulator in the next iteration. All right. And so in the next iteration, that accumulator is 450 now. Then here, the current movement is minus 400. And so here is 450 greater than minus 400? Yes, of course it is. And so let's simply return the accumulator so that it stays the same in the next iteration. And so that's the logic all the way until the end of the array. And with this, we then end up with this maximum value. All right, so I hope that made sense. And in fact, there is a ton of things that we can do with this reduce method. It is by far the most powerful array method that there is. And because of that, it can also be the hardest one to use. So we always need to think exactly what we want the accumulator and the current value to be and how they should interact. But I hope that with this exercise here, I could demonstrate the thought process a little bit. And throughout this section and the rest of the course, there will be some more exercises of the reduce method so that you can also learn better and better how to use it yourself one day. This is coding challenge number 2. And in this one, we're going to go back to Julia and Kate's study about dogs. And this time, they want to convert the ages of the dogs to human ages and then calculate their average age. So your job is to create this calc average human age function. And this function accepts an array of dogs' ages and it does the following 4 tasks. or actually just 3 tasks. So first, calculate the age of all the dogs in human years using this formula. So if the dog is less or equal to 2 years old, then the human age is simply twice the dog's age. But if the dog is older than 2 years, then the human age is calculated by this formula. Alright? Then, in the next step, exclude all the dogs that are less than 18 human years old. And that is essentially the same as keeping the dogs that are at least 18 years old here. Okay? Then, finally, calculate the average human age of all the adult dogs. And from the other challenges, you should already know how to calculate averages. Now in this one, you will do it in a different way, hopefully, because the goal of this challenge is of course to use the map, filter, and reduce methods. Finally, then run this function for both these test datasets. So as I said, this is a way of training the map, filter, and array methods that we just studied earlier. And so good luck with this challenge. Take all the time you need, and I see you here once you're ready. So, were you successful in solving this one? I sure hope so. And in case there was some doubt, here is my solution. So, this function takes an array of dog ages, and then we want to convert all of these ages to human ages. So what we want here is to create a new array based on the original array. And so for that, the map method is perfect. So we will have a new array called human ages, and that will be the result of calling the map method on the ages array. Then this callback function gets access to the current age, so the current element in the array. And now here what we need to return is the result of this formula. So this one here. And so let's write a ternary operator here. So if the age is less or equal to, then what we want to return here is 2 times the age, right? Because that dog age is of course this age variable here, because it comes from the ages array, which itself is an array of dog ages. Anyway, if the age is greater than 2, then the result will be 16 plus the age times 4. And so, since this has an implicit return here, remember it's like writing this here, okay? And so it's returning either this value here or actually either this value, so twice the age, or 4 times the age plus 16. So that's the callback function, and this will then produce the array that we're looking for. Let's take a look. So human ages, and then we just need to call the function. And so here is the age converted to human ages. And it does indeed look correct. So let's assume it is correct. Then, next up, we want to filter for all the dogs that are at least 18 years old. And so that will then exclude all the dogs that are less than 18 years old. So that's going to be the adult dogs. And so that is human ages. And now we use the filter method. And that makes sense, right? Because it's the filter method who allows us to set a condition like this one. So when the age is at least, so greater or equal 18, then put it in the new array, which will be the adults array. And so let's log that one as well. So actually I want both of them here. So human ages and the adults. And so indeed, these two here, the 4 and the 2, are gone. All right. And now finally, we want to calculate the average. Okay. And so the average is basically adding all of these values together and then dividing the result by 5, so the length of the array. So that's essentially what we already did before. So that's going to be adults.reduce, then the accumulator and the current age, and we want to return the accumulator plus the age, and the start is going to be at 0. So this here will return the sum, so all of these ages here added together. And so now all we need to do is to divide this by the length of this array. And then we simply want to return this average value that we just calculated. So let's just see if this makes sense. Let's actually save it here in a variable instead of logging it directly. So average 1, and then also average 2, and then just log both here to the console. And all right, here they are. And this looks pretty reasonable to me. And so our solution here works. Now, I just wanted to let you know that we could have done this average calculation here in a different way. So in a bit more complex way. So let me show you one property of an average. So let's say we want to calculate the average of 2 and 3. So we do that by 2 plus 3. So we add all of this together and then divide it by 2 because we have 2 values. And so that is then 2.5. However, we can also do it in a different way. So we can divide both of them by 2 immediately. So 2 divided by 2 plus 2 divided by 3. And this will also be 2.5. So these here are essentially the exact same thing. Okay? And so here we can do this differently. So let me actually duplicate this line so that we can keep both here. So what I mean is that we can actually simply divide the current age here immediately by the length of the array. Right? Here this is actually 3 divided by 2. Okay, sorry for that mistake. And so what we did here was basically to divide both of the values always immediately by the 2. And so that would be the same as immediately dividing the age here by the length of the array. So dividing this by the length of the array. And now remember that we can get this length immediately here from this parameter. Well, not really the length, but the array itself. So that's the 4th parameter. And so now we can say array.length like this. And so see what happens now here. And indeed, the values are exactly the same. And so this way of calculating it is just the same as this one here, but we can do it kind of all in one line. And I also wanted to show you a good use case for using this array here. In this case, we could of course also just have written here adults.length, but sometimes when we chain these methods together especially, then this is the only way we have of using the current array. And we will see a use case of that later. Now, of course, I did not expect you to write it like this, but I just wanted to show you a good use case for the current array parameter that we have here. Okay, and with that, we finished the challenge, and I see you in the next video.